Awesome. Artificial intelligence is overrated. Let me ask you one question to prove my point. Where is the intelligence? Before we go on to answer this question, let's back up to about 6 months ago when I received this message saying that the CEO of Quantify, one of the leading applied AI companies in Toronto, had read one of my nanotechnology articles and offered me an internship. Fast forward, and after completing the interview process, I started my full-time machine learning engineer internship the first week of August. So while I was working in the machine learning industry, one thing came to the shocking conclusion that artificial intelligence is actually not intelligent because it fundamentally does not understand the data. Instead, it's just focusing on curve fitting, whether it be 2 variable, 3 variable, or X variable. Almost all ML models today are focused on how we can optimize the weights and biases to match the curve of the input data. This is such a massive problem because we're limiting the possibility, endless capabilities of AI to this very simple, domain-specific, narrow curve-fitting stage. We're eliminating the chance to ever have logical reasoning or critical thinking, any of these important problem-solving traits in our AI. So ever since that day, I've always had this question in the back of my mind, is how can we improve AI? There must be a way we can improve the technology to solve this problem. And that's what brought me to the field of artificial general intelligence. Essentially, AGI is when we can get an AI model to demonstrate a human level of intelligence. Human intelligence is a pretty broad field, but it can be characterized as these 3 major pillars. A, the model has to be able to solve different tasks and achieve different goals in unique environments. B, the model has to be able to handle unforeseen problems. And C, the model has to be able to develop generalizable knowledge and skills that are applicable across different domains. So as soon as I heard about the field of AGI, I shifted my entire goal from nanotech to AI to looking at how can I accelerate the development of AGI. Now, let's look a little bit more about the comparison between AI and AGI. The perfect analogy to explain the capabilities of current AI is like a screwdriver. It's a very useful tool, but it can only perform one function. Performs that one function very well, but it's limited. AGI would be more like a toolbox, starting with the ability to understand which tool is required for your purpose, and then providing and applying it to solve the problem. This is why I believe AGI is the key to our future. Because AGI will not only enable me and millions of other people like me to solve problems that are so complex, they're unfathomable by today's AI. Problems, the beauty of AGI lies in the fact that I'm trying to build a tool that can replicate human intelligence, and we can apply it to as many different problems as we like. A great example, climate change. Let's take an example case study of how AGI would solve climate change. The system inefficiencies that contribute to climate change would be solved by the raw computational power of AGI. But the main focus of the model would be for developing the optimal approach while considering all the different factors, things like the social, different perspectives, the stakeholders, as in your slide, the legal barriers, indigenous rights, all these different problems will be able to come with the ultimate approach. The model will be able to run simulations and predictions, of altering all the variables to find which variables are the main needle movers and then tackle those. Now, I know AGI is a really long-term goal, and that's why the plan I have outlined here is my plan for getting myself to a level where I can start to build and iterate on a specific framework to achieve AGI. The first phase of my plan is focused on gaining the technical depth and understanding of the field of AGI. The second would be to pick a specific framework to double down on. And then finally would be to working with or working at top companies in the selected framework to tackle the needle movers in achieving AGI. Now, I mentioned frameworks a couple times, and there's broadly 4 main categories of frameworks known as approaches to achieving AGI. The first one is a symbolic approach. The symbolic approach was developed on the theory that knowledge is represented in our human brains through symbols. This is why if you look at the diagram here, it's very easy for our human minds to understand this. Because Apple, the structure, it's very intuitive for us. And a symbolic representation is actually encoded in the algorithm as well. A great example of a specific model in the symbolic approach is Actar. Actar is a programming language that was designed with principles of human cognition ingrained in it. Another approach is the Emergentist approach. And this is developed on the theory that intelligence emerges from sub-symbolic levels, which creates unexplainable data and actually really strongly represents current neural networks. For example, we do not understand what these values mean as a human mind, but this is how an output would be represented in today's neural network. In fact, the entire approach is based on looking at current day neural networks and iterating them and accelerating them to a level where they can achieve AGI. Another sub-example of the Emergentist approach that holds a lot of promise is hierarchical temporal memory. So HTM is an unsupervised learning model that's on a really great path to achieving a machine intelligence because of its ability to store, learn, and generalize between patterns in sequence data. HTM is built upon the thousand brains theory of intelligence, which it differs from the traditional theory in machine learning. Thousand brains theory states that every single column in a neural network actually has a fully built representation of the final output. Now, circling back to what I mentioned before about how we're looking at iterating on current neural networks, an HTM can be thought of as the next iteration of an LSTM, which is a type of recurrent neural network, mainly because they both have the signature loop, which allows them to process sequence data and come up with one conclusive output. Now, with the million-dollar question. The main reason that HTM is on a path to AGI and it's differentiated in all these other models, so instead of using backpropagation and traditional gradient descent in its learning, HTM actually uses something known as the Hebbian learning rule. And the Hebbian learning rule was a rule that was developed based on the principles of neuroplasticity. And it states that the connection between any two neurons is strengthened if they're both either simultaneously on or simultaneously off. The next approach is exactly what it sounds like. The hybrid approach is combining both the symbolic and emergentist approaches to achieve cognitive synergy. So OpenCog, which is the pioneering organization in this field, has developed a real-time hypergraph representation of both the symbolic and sub-symbolic knowledge in something known as the atom space. A couple of different models and architectures that are working together in the atom space are visible in the diagram on the left. And within the atom space as well, it's hard-encoded a specific cognitive architecture in which it divides the word intelligence into separate sub-cognitive units, with each one of them being represented for each one of them responsible for one type of information and trying to achieve one very specific aspect of intelligence. The final approach to AGI is a universalist approach. And this is looking at how we can build AGI with unlimited computing power and then scale down to implementation. So the primary model in this field is the AXC architecture. So AXC is a type of reinforcement learning model, which means it learns through performing actions and receiving positive and negative feedback from its environment. So the AXC model works by before taking any action, it actually references all of its previous actions and the corresponding rewards. It then uses the Bayes theorem. The Bayes theorem is a way to systematically update probability in an ML model. Use the Bayes theorem to update with which of all of its past actions will be predicted to get the best reward for this current scenario. Then applies that specific action. And boom, continuous repetition. So these were the four main approaches to achieving AGI today. Now, I know that I have a long journey ahead of me because I'm just getting started, but I could not be more excited because someone needs to be driven enough to persist through the hundreds of hours of failure, motivated enough to devote their time and energy to advancing society forward, stoic enough to not care about other people's opinion and to conform to society, and lastly, ignorant enough to take on a long shot like this. And that person is me.